Okay, so we are here again today, and we are done with advanced JavaScript concepts. We are going to be jumping into Node.js. Node.js. The reason why we are all here at KodeCamp, Node.js. And first of all, start with this part and the code Node.js. Do things the Node way, like trying to understand how Node works, how it handles inputs and outputs, event demultiplexer, event loops, and all of that. So without wasting much time, let's jump into it. As you can see, we have Node.js philosophy and design fundamentals. We try to understand the Node.js philosophy, the principles behind Node.js, the design patterns, and how we can use them. The guidelines that are generally accepted by the community, and an ideology of like doing things that they say influences the evolution of the platform or something like that. So first of all, start with the Node.js philosophy. And as you can see, the node has a small core. Small core simply means the Node.js core is built with a few principles. And one of these principles is having the smallest set of functionality. The Node.js core has the smallest set of functionalities. It leaves the rest to the user, to the user space or the user land. That's how they refer to it, the user space. The user space is the ecosystem of modules living outside of the core. This gives freedom. The Node.js having a small core gives freedom to the community to experiment and iterate fast on a broader set of solutions. Within the scope of the userland modules. So in general, what you're trying to say is the node has a small core, a very, very small core, leaving the rest to the userland. That's the node community, the ecosystem. Yeah, Moses, go on.
Good afternoon, sir.
Good afternoon.
Sir, we can't see your screen.
You can't see my screen?
Yes, sir.
Hold on.
Can everyone see his screen?
I think I could see
Yes, I
only
can
the
see the
slide.
screen.
I could see the slide.
Can you see it now?
No. Maybe I'm the one having the issue here. I'll check.
Yeah,
Well,
yeah.
can
I can see
everyone
it.
else see my screen?
Yeah, I can see it. So
Okay.
I think Moses should check.
Okay, I'll check.
Okay. The second item on the list are small modules. Like Node.js uses the concept of module as a fundamental means to structure the code of a program. That is, the module is like a file that you can import and use in another file. Having this, like, it is a brick for creating applications and reusable libraries called packages. This module are like the foundation of creating reusable libraries. In Node.js, the reusable libraries are called packages. Like install this package, install the Axios package, install this one, install that one. They're called packages. And in other words, a package can simply be referred to as a module, yes, because you can import it and then simply use it like that in another file. And this it's very important when it comes to scope. But we'll be emphasizing on that later. We should just know that the Node.js has a small core and small modules where you can write just a simple, you can implement a simple functionality and import it in another module and use it, and you can even reuse it. This principle has its roots in the Unix philosophy. Some of us that knows the Unix operating systems, Unix-like operating systems, like particularly in two of its precepts, which are small is beautiful and make each program do one thing well. Small is beautiful and make one program do one thing well. When you write your code and you try to abstract logic, you try to create small modules so you can reuse them. It makes it makes them easier to understand and use. You can easily maintain them and test them. You can even share it with the browser. Like having smaller and more focused modules empower to share or reuse even the smallest piece of code. That is where the don't repeat yourself principle comes in. The don't repeat yourself drive. It's applied to the whole new level. I mean, the whole system where you have to write your code, you keep it clean and you don't repeat yourself. You write one function, and if you want to reuse that function, you don't need to write it again. You simply import it in any other module and then you reuse it. And Node.js also has a small surface area. In addition to being small and in size and scope, Node.js scopes, modules also have this characteristics of exposing a minimal logic or minimal functionality. You have your private functions and private methods and properties. Then the public ones, you only expose the public ones for usage, and you keep your private ones and process what's kind of write whatsoever kind of logic you want to write. So that's where the small surface area comes in. You may have a complex logic that you want to write or you've written in your code, but simply you want the users to have access to a minimal surface, like one or two functions that you expose to them to simply use your logic. So that makes Node.js this small surface area kind of a thing. Let's leave it like that. And next on the list, we have simplicity and pragmatism. Another principle comes in here, which is keep it simple. Keep it simple, stupid. And they abbreviate it as KEYS. Is that an acronym or an abbreviation? I don't know. KEYS. Keep it simple, stupid. KEYS principle. So the simplicity and the pragmatism introduces this principle. You design a simple and a feature-full software. Like by exposing minimal functionality, you design a free feature software without polluting your code. It makes it easier for you to make your code powerful and then clean. And in NodeJS, this principle is also enabled by JavaScript, which is very pragmatic language. I know most of us don't know that. It's not right. In fact, to see simple functions, closures, and object literals replacing complex class hierarchies. Pure object-oriented design often try to replicate the real world using the mathematical terms of a computer system without considering the imperfection and complexity. Yes, and they say pure object-oriented designs. JavaScript. If you ask a developer, is JavaScript an object-oriented programming language or it's a functional programming language? They will tell you they don't know, because actually, to me, JavaScript is partially functional and it's partially OOP, because prior to ES6, implementing object-oriented patterns, you have to use functions as constructors before they introduce classes. So to me, JavaScript is functional, it's partially functional and partially object-oriented. So all these small modules, small software, small code, amounts with simplicity and pragmatism, where you keep everything simple, in order not to be stupid. And then try to make some abstractions and make your code cleaner and your app powerful. And that is just the beginning. Let's delve into, let me say, the real deal, the design fundamentals. And here we are again, the reactor pattern. Whoa. Oh, reactor pattern. So what exactly is the reactor pattern? This pattern comprises of so many small units, like inputs and outputs. Is definitely is the slowest among the fundamental operations of a computer, like accessing the RAM and accessing data from a disk and doing all kind of input and output operations. So in this case, other let's say other web servers or other NodeJs-like platforms, their IO is blocking. And how NodeJs differs from this platform is it's quite simple and interesting. We'll get to that soon. Like in traditional blocking IO programming, the function call corresponding to an IO request will block the execution of the thread until the operation completes. When you send the request, and when you send the request, let's say you send the request to a server, I also send the request. The server will have to process your own requests, and it will have to complete it before it will start processing my own. And that will, let's say, range from seconds, minutes. Let's assume your operation is quite time consuming. So it will take like 5 minutes to process yours. I'll keep waiting for 5 minutes, which is a bad user experience. I mean, even get angry and decide not to visit that website again because of this. And approach to handle concurrency in web servers is to kick off a that's where single-threaded and multi-threaded concepts comes in. For each concurrent connection that needs to be handled, it will kick off a thread. This way, when a thread blocks for an IO operation, it will not impact the availability of the other requests because they are handled in separate threads. So in this case, when you send a request, the server will kick off a separate thread that will handle your request. Then if I send my own request, the server will also kick off another thread to handle my own request. And you know that will consume resources. When by the time millions of people send in requests and the server kicks off a million threads to handle all these requests, you know, it's let me say it's memory consuming or storage consuming. What should I say? But to consume the memory, let's assume you have just a gig of RAM on your web server and a million or two decide to send in requests. You know that the memory will be exhausted. That so the non-blocking IO solve that problem. No, in addition to a blocking IO, most modern operating systems support another mechanism to access resources called non-blocking IO. In this operating mode, the system call always returns immediately without waiting for the data to be read or written. Yeah, Joshua, go on.
Yeah, okay. So Node.js is a single-threaded framework or something. But
Yes.
how is it able to manage like different requests coming in at the same time?
Okay, we get to that.
When
We're
it's
heading
not
there.
okay.
We won't be writing much code today. We'll talk about Node.js, how it works and handle requests. So this is the blocking IO. This is the first connection, the second connection, the third connection, and this is the server. So when the first connection comes in, it kicks off this thread that handles data from A. The second connection comes in, it kicks off this thread that handles data from the B connection. Then the C connection comes in, it kicks off this thread to handle data from the C connection. And you can see this is let me say messy. This is not too good. So the non-blocking IO comes in. Now, most modern operating systems support another mechanism to access resources called the non-blocking IO. Then in this operating mode, the system call always return immediately without waiting for the data to be read or written, as I earlier said. If no results are available at the moment of the call, the function will simply return a predefined constant. And we'll be even writing code that emulates that behavior, indicating that there's no, if it returns a predefined constant that indicates that there's no data available to return at that moment. So, like the non-blocking IO, I would love to show you, let's say, a pseudocode, but there's no need for that. We'll get to that in the meantime. But the most basic pattern for accessing this kind of non-blocking IO is actually, let's say, poll. It polls the resource within a loop until some actual data is returned. This is called busy waiting. When it returns a constant immediately, it will have to wait till the actual data is returned. That is, the actual data is processed and then the result will be returned. Something like that. So this takes us to event demultiplexing. We're still on the reactor pattern. And busy waiting is definitely not an ideal technique for processing non-blocking resources. But then most modern operating systems provide a native mechanism to handle concurrent non-blocking resources in an efficient way. The mechanism is called synchronous event demultiplexer or event notification interface. So this component collects and queues IO events that come from a set of watch resources and then block until new events are available to process. So it's interesting to start this part. We can now handle several IO operations inside a single thread without using a busy waiting technique. That's it, event demultiplex. Like when the first IO comes in, it applies the technique of non-blocking IO. It returns a predefined constant, indicating that there's no data to return at that moment. Then it processes the data, then returns data to replace that predefined constant. When it seeks in, it adds the connection B to the thread. Why this is busy processing its data, it adds the connection B to the thread time that there was no request, there was no incoming request. So during this time, there was no request. So let's say the thread was free, it was not processing any data. So when the request comes in, it pushes it to this thread, and the thread processes the data. It first of all returns a predefined constant, then processes the data and returns it to this connection. So we are going somewhere. We first of all discuss about the blocking IO and how it's not good, how other web servers work. That's how they work. They use the blocking IO, which is not good. And this is event demultiplexing. We are trying to understand how NodeJs combines all this together and how that makes it efficient. And now this takes us to the reactor pattern. The reactor pattern. You can see, yeah, Josh.
Yeah, this event demultiplexing doesn't mean that as the request comes, it's like puts them in a queue.
Yes. Okay. We'll discuss that now.
Okay.
You know, NodeJs works on event-driven architecture, and it has an event demultiplexer and an event queue. All input and output requests generate an event, and these events are processed as they are processed in some steps. Like let's what happens here is this event demultiplexer collects input and output requests from this application. Let's say from this application, this application sends request to this event demultiplexer. Then once these IO are once they are processed, the inputs and outputs requests, once are processed in the event demultiplexer, as we said, once they will first of all return a predefined constant, then process the input request. Then once they are processed, the event demultiplexer add a callback handler to the request and send it to the event queue. Look at the handler here. It adds the handler, send it to the event queue. When events are available in this event queue here, event loop processes them in sequence until event queue gets empty. You know, This event loops here processes all the events in this event queue till they are empty. When it processes them, then it passes back the result to this handler. The handler will return the result to the application, of which the application will either send in another request to the event demultiplexer or will return the execution context to the event loop. At first, this may be difficult to understand, but the event loop is the main thing here. Okay, let me just speak grammar a little. The application generates a new input and output, or let's say input or output operation, but submitting a request to the event demultiplexer. It generates an input and output request by submitting a request to the event demultiplexer, as you can see. So this application also specifies a handler which will be invoked when the operation completes. It defines a handler. In most of our cases, we normally call it a callback, but we'll get to that in a minute. The application also specifies a handler which will be invoked when the operation completes. So submitting a new request to the event demultiplexer is a non-blocking call, and it immediately returns the control back to the application. Can you see this dotted arrow here? Once you submit a request to the event demultiplexer, it will return control back to the application. Either it will return a predefined constant or some kind of value to indicate that yes, your data is being processed. And that is the first step. You send a request, and event demultiplexer returns a predefined constant or a kind of control back to the request. So when the set of IO operations complete, the event demultiplexer pushes the new event into the event queue. When the operations are complete, okay, let's say you want to fetch data or do some kind of logic, anything you want to do. Once the operations are complete, this event demultiplexer will push the new event into the event queue. Can you see that the events are being pushed? This is the event, and this is the handler. This is the event, and this is the handler for the event. In this case, we may refer to this handler as a callback. So at this point, once there are events in the event queue, the event loop iterates over the items of the event queue. For each event, the associate handler is invoked. Once it iterates, you know how iteration works now for the for loop or all those things. Once it gets to a particular event, it will invoke the handler. So what did you specify your handler in your application? Let's say you specify that, okay, once this event is complete, return the result to me. So the handler, which is part of the application code, that is where you specify the handler here in your own code. The handler, which is part of the application, will give back the control to the event loop when its execution completes. When the handler is invoked and its execution completes, it will give control back to the event loop. So when you give back the control to the event when its execution completes, now new asynchronous operation must be requested during the execution of the handler. Let's say at this point that this event queue, this event loop iterates over this event queue, and then this handler is evoked. This event loop, what it does is the execution of the handler. During the execution of the handler, there may be a new request here. So if there's a new request, this request will be sent to the event demultiplexer, causing new operations to be inserted in the event demultiplexer. So before the control is given back to the event loop, when all the items in the event queue are processed, the loop will block again on the event demultiplexer, which will then trigger another cycle. This is done in cycles. When this is complete, the loop will block. it will stop execution at that moment until the event demultiplexer pushes other events into the event queue. Then this loop will execute again, processing all these events, then executing their handlers. Once it's done, it will pass the execution back to the application. Yeah, just go on.
Sorry, these events and handlers, do they mean like requests?
Yes, they can be requests, they can be anything. You know, this is quite a complex thing. These patterns are used in designing other applications and complex softwares. Let's say React. One of these patterns is used in designing React. So if you say request, you're partially correct because you may want to read a file asynchronously, and then the request will send it to the event demultiplexer. After fetching the file, this event demultiplexer will then pass that event to this event queue. Then the handler you specify in that asynchronous read file, that handler, then after this event will iterate over, then when it gets to that read file function, the callback function, which is the handler that you pass into that read file, will be evoked. Then that is when the event loop will pass back the execution context to the application. That is where your data will be displayed on the console, or you can do anything with your data or something like that. So at this point, it may seem confusing, but then you may have to take your time, sit back, and try to observe all these things and how they work. But then I will not stop there. Let me still explain this. The event loop now is the real hero in the Node.js architecture. Yes, let's say the real hero, which makes Node.js a non-blocking and asynchronous. So the event loop is single-threaded, and it's an infinite loop, but not really an infinite loop. It's a semi-infinite loop, because by the time the event queue is empty, it will stop iterating over it and block the iteration till the event demultiplexer pushes in new events inside the event into the event queue before the loop will also iterate again over the event queue and then pass the execution to the application again. So let's call it a semi-infinite loop. It is called a semi-infinite loop because it exists at a point when there's no work. As I earlier said, if there's no work here, if there's no event in the event queue, it will exit. It will stop iterating over the event queue till the event demultiplexer pushes in new events into the queue. So the event demultiplexer exists in different systems, different names, like EPO on Linux, KQ in BSD systems, IOCP, which is input output completion port in Windows. Node.js use this low-level non-blocking asynchronous hardware for input or output functionalities provided by these systems. And as you can see, you cannot see actually, but for your information, not all inputs or outputs can be performed using these hardwares. File operations cannot be performed asynchronous using these systems. To resolve these complex input or output functionalities, thread pool is introduced. There are some complexities with some input-output operations which requires more time to get processed. Modules like the FS, that is the file system, the crypto, database operations, and all of that. To avoid the blocking of event loop, thread pool, also known as the worker pool. Yeah, the worker pool concept is added to Node.js. And that is where LibOf comes in. the non-blocking IO of the NodeJs engine. Non-blocking IO engine of the NodeJs, the LIBOR. Each operating system has its own interface for the event demultiplexer. Each operating system has its own interface for the event demultiplexer. And before I move forward, that's why I always emphasize on, software engineering is not all about writing code. Yes. All you may want to do is simply, I'm a Node.js developer. I don't have anything. I'm not really a software engineer. You are a software engineer because you'll be solving real life problems, except you just want to sit at home and eat food. Once you decide becoming a software engineer, in Nigeria, we say we want problems always, because you will encounter problems and all they need from solutions. If you can't provide solutions to problems, then you are as good as useless. And that is what makes a good software engineer. Problem solving. You have to be quick in reasoning and quick in solving problems. So before you jump into software engineering, I always advise students to take a general look at software engineering concepts, try to understand how operating systems work, how they process data, how they handle data, how processors interpret or compile code and all of that. You need to understand how the operating system works, how the computer memory and how the RAM works, how the RAM differs from the primary and secondary memories and all of that. So that will help if you invest time in trying to study and understand all of these things, because they are very, very important. So for example, now, maybe after KodeCamp, you get a job and you'll be required to build, let's say, is software as a service. You're required to build a SaaS platform like software as a service, where you deploy other applications. Then, for instance, someone writes code on a Mac and wants to deploy on your system, and you are not using NodeJs as your web server, you are using Nginx or Linux or operating system or other things. You need to know how to handle all these things. If you don't know how the computer works or all of that, things will become messy, and you have to invest time, come back again, and then study all these things to understand how everything works before you be able to understand. Because once you don't understand that 1 + 1 is equals to 2, then you will not understand that 5 + 5 is 10. You won't understand. You have to, if you want to master anything, this is simple saying, but it's very powerful. If you want to master anything, master the basics. Like when I started studying maths, for me to master maths, I mastered the basics. When you master the basics, when you come across anything that it's complex, you break it down. And when you break it down, you still come back to the basics. That's where you break it down, then you solve it piece by piece. As simple as that. So, as I was saying, each operating system has its own interface for the event demultiplexer. So, for example, in Unix, regular file system files do not support non-blocking operation. So, in order to simulate a non-blocking behavior, it is necessary to use a separate thread outside the event loop. All these inconsistencies across and within the different operating system required a higher level abstraction to be built for the event demultiplexer. And that is where the LIBOR library came in. That is exactly why the Node.js core team created the C library called LIBOR. LIBOR is built with C. Node.js is built with C++. And C++ is the superset of C. C is a functional programming language, while C++ is object-oriented. Yes, they tried to, they kind of converted C to C, improved its functionalities to C++ so that you can easily use it to build projects using OOP principles. So with the objective to make NodeJS compatible with all major platforms and normalize the non-blocking behavior of the different types of resources, LibOps today represent the lower level IO engine of NodeJS. Yes. So that takes us to the final architecture of the NodeJS. So the reactor pattern and LibOps are the basic building blocks of NodeJS, but we need the following three other components to build a full platform. A set of bindings responsible for wrapping and exposing LibOps and other low-level functionalities to JavaScript. Here, a set of bindings responsible for wrapping and exposing LibOps and other low-level functionalities to JavaScript. V8 JavaScript engine, originally it was developed by Google for the Google Chrome browser. This is one of the reasons why Node.js is so fast and efficient. You know, V8 is acclaimed for its revolutionary design, its speed, and for efficient memory management. Then a code Node.js library called NodeCore that implements the high-level Node.js API. This NodeCore implements the high-level Node.js API, or the FS, and all the APIs that we use in building our applications. And this is the user land, the modules and the application, where we import all of these APIs, the FS and other things, where we import and use and build our applications. So this is the Node.js system, and this is what makes up the Node.js architecture. The V8, the LibOps, the bindings, and the core JavaScript. I believe by this time we should know the use of all these things, because I talked about this LibOps, what it does. It resolves the problem of different operating systems not being consistent with Node.js. Some not supporting I/O asynchronously, some supporting synchronously, and all of that. That's what the LibOps solves. Then the V8 that handles memory management and all of that, which was built with the Chrome browser, and that's what makes Chrome browser the best browser for web dev, for debugging, and every other thing. Then the bindings, a set of bindings responsible for wrapping and exposing LibOps and other low-level functionality to JavaScript. You know, as I earlier mentioned, LibOps is built with C, so it will expose some APIs and low-level functionalities to JavaScript, so that JavaScript can be able to access them and then make use of them in this Node.js architecture. So can we see how amazing Node.js is and what makes up Node.js? It's not a programming language. It's single-threaded, but then this LibOps and V8 built with C++ makes it multi-threaded that can handle requests asynchronously. That's much though. We may not understand, but then we get to understand better if we keep doing it. But if you understand the reactor pattern, then you will understand Node.js. But then we have other patterns. We discuss reactor pattern, callback pattern, the module system, and patterns. But we will not discuss the observer pattern. I will leave it to you. It's a kind of more advanced. Then I will leave it to you to research on it by yourself. But let's move over to the callback pattern. We've discussed the reactor pattern and the code architecture of Node.js, the reactor pattern, which comprises of the bindings, the V8 engine, the LibOps, and the core Node.js API that's exposed to the users to be able to use the Node.js platform. Okay, and this brings us to the callback pattern. Most of us have been using callbacks, but we don't really know what callbacks are. We don't know how. Sometimes we use it asynchronously, sometimes we use it synchronously without knowing what exactly we are doing. Like callbacks are the materialization of the handlers of the reactor pattern, and they're literally one of those imprints that give Node.js its distinctive programming style. Like callbacks are functions that are invoked to propagate the result of an operation, and it is exactly what we need when dealing with asynchronous operations. I believe we all know what propagation is. If you don't know, you have your phone with you, just Google it or search it in a dictionary. Propagation is simply transferring control to other parts of your code by simply invoking a function or throwing an error or something like that, but simply transferring control to another part of your code, either a function or a higher level or lower level. That is propagation in overview. So, the practically replaces the use of return instructions that, as we all know, always execute synchronously. JavaScript it's a great language to represent callbacks because, as we know, functions are first-class objects and can be easily assigned to variables. That is function declaration and expressions. When you assign a function to a variable, it becomes a function expression. You can even pass arguments, return from another function in which, or store into data structures, or all of that. And the callback pattern has two styles. We have the continuous passing style, in short form known as the CPS. So a callback is a function that is passed as an argument to another function and is invoked with the result when the operation completes. Let's say in functional programming, this way of propagating the result is called continuous passing style. As I earlier said, also known as the CPS. It's a general concept though, and it is not always associated with asynchronous operations. What it indicates is that the result is propagated by passing it to another function, which is known as a callback, instead of directly like returning it to the caller. So let's say we're going to be taking on some examples to understand the continuous passing style. In particular, we'll start with the synchronous continuous passing style. And for instance, we have, let's make the folder and call it as CPS. Let's say SPC, SCPS. That is the synchronous continuous passing style. Yes. So for instance, we have a simple function that adds two numbers and returns the result. This is simply a function, and this style is called the direct style. This style of writing a function like this that immediately returns the result is called the direct style. And it's present in almost all common ways of returning a result in synchronous programming. So the equivalent continuous passing style there is a synchronous continuous passing style. You can even pass in a callback, then you can see inside this callback the result. Now, when it comes to callback, most of us become confused. And this here is synchronous. Let's try to use this function. We call this function, let's say, add 2 and 7. Then the next argument is a callback. Let's see, the callback is a function that takes the result of this function. When it adds 2 and 7, it passes it. It's a continuous passing style. It passes the result to this function. And what this function simply does is logs the result to the console. Let's say result. Let's just simply say result like this. And then let's try to test this out. Yeah. Oh, this is A plus B, not simply. Yes, and we have 9. So what's happening here is this function, when after adding A and B, it will pass the result to this function, this callback here. Look at what the callback is doing. You pass in the callback, and the callback returns the result. So in this case, this is the callback, and this is the result you are passing, the A plus B, which is 9. Then it logs the result to the console. So this is synchronous, and you can even abstract this. You can use the function here, place it. Let's say you place it above. You simply say display result. You simply add your display result here. Can you see what's happening? I did not call this function. I did not invoke it and pass any result. I only passed it as an argument. But can you see the magic? What this is automatically passing the result to this function, which is the result here, then logging it to the console. Then you can even see result times 2. You're having 18. In my that is cool. That is cool. And this is synchronous because you can say say log A log adding, or let's say added. Let's say log done. Or let's return this here to make it clear. And then we bring down this one here. So place it here. Then run it again. You can see we have our A. The result is returned and multiplied by 2. We have our 18. Then we logged our address to the console, then logged done, which shows this is synchronous. So this is the synchronous continuous passing style. So in the asynchronous continuous passing style, you can simply, in the callback, you cannot just, instead of like simply returning the callback like this, you can say, you can do something like set time out. You know, set time out takes the function. Set time out, not the callback directly, but a function first. Let's see, function, then the callback, and then let's say 3 seconds. And then let's test this out and see what happens now. Can you see that? We immediately got our A back, but the done is at the end. Well, we got our done before the result was processed and returned. So this is asynchronous. It will take 3 seconds for this to execute, but this one is here is synchronous. Now let's see what exactly is happening. The asynchronous continuous persistent. This is what is happening. Let's assume the first console log we had was yes, Yobu, go ahead.
Yeah, hi.
Yeah.
So I want to ask, like for the functioning of past callback, is
Yeah.
it always have to be callback, or you can name it like a
Okay,
name
you can name it
callback?
anything. I like naming it fn. That is a function.
Okay.
Then you can come here and say fn, and everything works perfectly.
Okay.
Yeah, you can name it anything. You can even name it village people, but it will still work. Yeah. So this is what happens. So when you log this to the console, let's actually define this function here. It's an add async, async, not async, async, add async function. Okay, so let me define the function and use it to the ACPS. Yes. Let me make this as synchronous. Okay. Okay. So I will use this function as an example. So let me just add async AB. This is a callback for clear understanding. Let's set time out. Function with your callback A plus B. This callback A plus B is what the function will be doing. The function is this callback will simply add A and B, then do anything, either log it to the console or pass it to another function or do whatsoever it wants to do with it. Then you come here, you log before, as you can see, before, after, log, okay. Before, then you call your function add async, and you pass in 1, 2 as shown in the diagram. Then you pass in your callback function result. You simply say log result you say plus result concatenation. Then you come down here and you log after. And the set timeout will take 2 seconds. Now let's test it out. Before, after, the results of concatenation. Before, after, and result 3. Now let's try to understand what's actually going on here. This is the event loop. The black lines, you see the black arrows or black lines or whatsoever. The black lines indicates the function invocation, and the dotted lines the transfer of control. So this function is invoked. This log, console log function is invoked. If the print before, then the execution context it processes to the add async. Then add async invokes the set time out. Now the set time out transfer control back to the add async. Then the add async transfer the control to the console.log after the function. So this log after then finishes the execution, as you can see. It finishes the execution, but then the set timeout is still executing because it's waiting for 2 seconds. Then this passes, it transfers the control back to the event loop. So when the async operation completes, the callback function invokes, then it executes the console.log function that logs the result on the console. Then after logging it, it transfers control back to the callback function, and then this callback function transfers the control back to the event loop. Can you see that? And what is happening here is what we discussed earlier about the event demultiplexer and the event queue. So what this event loop is doing here is when it gets to this function in the event queue, this is what will happen. Let's say this is an event with a handler, and this is the handler. The handler is this callback, which is passed in as the result, and the result is passed in the handler. So when the handler is evoked, the event will be activated. When it gets to this event, the handler will be evoked, then pass the control back to the application. The asynchronous continuous passing style. So understanding this concept helps us a lot to understand what NodeJs or JavaScript is actually doing. Yes, it helps us to understand what JavaScript is actually doing. So this takes us to non-continuation passing style. We've actually looked at the synchronous continuation passing style and the asynchronous continuation passing style. Then now we'll look at the non-continuation passing style. Now, there are several circumstances in which the presence of a callback argument might make you think that the function is asynchronous or is a kind of using a continuation passing style. But that's actually not always the case. Let's see, for example, the map method of the array the map function of the array. Let's assume this is the NCPC, the non-continuation passing style. This is NPCS. Let's say we have an array of 1, 2, 3. Map. Now we have a callback. Even here you can see callback function. A function that accepts up to 3 arguments. The map method calls the callback function and all of that. If you understand higher order functions in JavaScript, you will know that the higher order functions, most of them accept 3 arguments: the index, the array, and the value. I mean, the callback function, the index, and the array. But mostly, only the callback function is used. Let's say, in this case, we are passing in a callback function, but we're not passing any value to the callback function. The callback function is simply performing a specific function. Like, in this case, let's say we have a callback function of let's say value that simply return value. Okay, let's say -2. let's say let result equal to this. Then we can try to log this on the console. Let's see what happens. Node ncps.js. As you can see, 1 minus 2 is -1, 2 minus 2 is 0, and 3 minus 2 is 1. So this callback function here is not used for any continuation, passing style, or whatsoever. It simply iterates over the elements of the array and not pass the result of the operation. It will iterate over these elements and it will not pass the result to anywhere. It only iterates over it and returns the result. So using asynchronous or synchronous patterns in your code, it all depends on you. It depends on what you want to do or what kind of functionalities you want your code or your app to have. And then all of that, it all depends on you. But you have to be very careful when using asynchronous and synchronous methods. You just don't jump into code and then write whatsoever you want to write. And as I will always say, the end of a project, every project, planning of that project determines the end of it. If you plan rubbish, you end up with rubbish. But if you plan well, then you plan whiteboard, write down things, take advantage of every opportunity, and then work as a team. Then you come up with something unique, and then you bring down options where you'll be able to choose a preferable one that will suit your project. You don't just jump over choosing, you don't write asynchronous code and jump in and then start writing synchronous code. You want to break your code. Let's know how it's done. So that's it. So let's move over to the NodeJs callback conventions. NodeJs callback conventions. Okay. Let me make another folder. Callback. Can index.js here. In NodeJs continuation passing style, APIs and callbacks follow a set of specific conventions. These conventions apply to the NodeJs call API, but they are also followed virtually by every user land module and application. So it's very important that we understand them and make sure that we comply whenever we need to design an asynchronous API. Yes, very, very important. And in NodeJs asynchronous continuation passing style, the callbacks comes first. In NodeJs, if a function accepts imputes a callback, this has to be passed as the last argument. Okay, let's say let's use the file system, for example. Let's say fs dot I'm not imputing it. I just want to show you an example. Then we have, first thing is the file name. The second thing, options. And the third is the callback. Callback comes last. the callback always comes last. Always have this at the back of your mind. And as you can see from this simple, let me say pseudocode or a signature, as you can see, the preceding function, the callback is always put in last position, even in the presence of option arguments. Yes. The motivation for this convention is that the function call is more readable in case the callback is defined in place. Yes, because no matter how complex the callback may be, if you don't want to abstract it, you will just leave it in your function, in your read file function, and you write whatsoever logic you want to write inside, but so far it comes last, it will be easier and simpler to read. Yes. Then errors comes first. Errors comes first in your callback function. In the continuous passing style, errors are propagated as any other type of result, which means using the callback in NodeJs, any error produced by a continuous passing style, that is a CPS function, is always passed as the first argument of the callback, and any actual result is passed starting from the second argument. Yes, if the operations succeed without errors, the first argument to be null or undefined. Yes, it will be null or undefined. Okay, let's see how we can actually define a callback with the convention of defining callbacks with putting the callbacks last and the functions come in the callbacks first. Let's see, we want to read a file. Fs or read file. We have a file name, simply file name. The character encoding. Let's say in this case we have UTF-8, universal character encoding. Then we have a callback function, which takes the error first because the error comes first. Then the data returned, the data being read from that file. Then we handle the error first for the data. If there's any error, handle error here. Handle error. If there's no error, you can add else. Something like an else, okay, let's say else. Process data. This is simply the convention. All we've been saying that the callback function comes first and the error in the callback function comes first as well, while the data comes second. So that is just it for this convention. And it is a good practice to always check for the presence of an error. As not doing so will make it hard for you to debug your code and discover the possible points of failures. If you don't handle errors, you don't really know what's happening. Your application may be failing, but you don't know because you are not handling errors. So you have to like take your time again and debug without finding results. So propagating errors in asynchronous direct style function is done with the well-known throw command. You see, let's say if this error, throw, you can say throw new error, may pass in the error, or you can simply say throw, instead of throwing new error, calling the error object, you say throw error like this. That is in the continuous passing style. You can simply do something like that. But then In asynchronous CPS, however, proper error propagation is done by simply passing the error to the next callback in the CPS chain. Always remember that CPS is continuous or continuation passing style. So let's try to see how this actually works. Let's say you have a function that reads a JSON file. For instance, you have a function like this, read JSON, and then you have, you know what, let me just import fs. Oops, I don't have. Fs. So this is our file that will read a JSON file. Then in here, it takes a file name and a callback. Takes in a file name and a callback. Then we want to read a JSON file. So we see fs.read file. We're not reading it synchronously, we're reading it asynchronously. So we remove this. Then we pass in the file name that is specified as the parameter in this function, the file name, and the character encoding, UTF-8. I love this one. See something UTF-8. Then the callback function, a callback function for the read file. Function error data, like this. Then we say let pass. If error, then return callback error. This callback that is passed in as a parameter. We pass the error to the callback and then return it. Then we we'll move on to handle errors properly with the try catch block. So we say in the try, here we want to actually process our data. We say pass is equal to JSON dot pass data. JSON dot pass data. So is there any errors? If there are any errors, we want to simply return the callback and pass in the error inside the callback. If there are no errors, we will propagate simply the data. And where are we propagating the data? Here. You say callback. No, always remember that the first argument in the callback is an error. So if there are no errors, simply pass in null and then propagate the data passed. Here, passed is assigned to undefined because there's no value as it's declared but not assigned to any value. So if there are any errors, we pass the error to the callback and we return it. If not, we try here to like process our data. Then we assign JSON.pass data, then we return the result and assign it to pass. Then finally, if there are any errors in trying to process the data, we return a callback and pass in the errors. If there are no errors, we propagate our data with no errors. Can you see this? this proper handling of errors. Proper handling of errors in our function using callbacks. So most of us may get confused why it is like this, but it is simply like this because this is how it's supposed to be. You know, in handling errors in our code is very important, and we have to follow the best practices in handling errors. And I think that is all for that. And if you want to really use your file, let's say we have a names.json. Okay, this is a JSON file. And we have, what does a JSON file looks like? Like this? Okay, yes. Like this. Okay, we'll come here and we'll say something like read JSON. Then we'll have names.json. And we'll have a callback function that takes in the results and then logs the result to the console. Okay. Let's try to see. Index the JSON callback. Okay, node. No. Names.json. We really did not handle errors. Okay, the file name callback. If it's a read file name function data pass JSON.pass data callback. Okay. So we have our error and the result. If error log error. Now log result. Yes. The reason why it returned null because we did not handle errors. So this is very, very important. As you can see, this is our JSON file. We read it, we passed it, then we return it with proper error handling. So that's it for error handling in CPS. So let's look at what next we have. We've looked at Node.js callback conventions. And the next is the module system and its pattern. We've looked at the callback pattern, the reactor pattern. The next is the module system and its pattern. And in this pattern, the first on the list is revealing the module pattern. So the revealing module pattern, not the revealing the module pattern. The revealing module pattern is a design pattern actually used in JavaScript, including NodeJs, yes, to create modular and encapsulated code. It allows you, as I've always been saying, it allows you to expose only specific functions or variables from the module, keeping the rest of the module's internal details private. Let's say, for instance, we have um, oops. Okay. Now we have our modules. So let's see an example of how revealing the revealing module pattern works. We have a function. Let's say we have a function of module is equal to, this is IIFE, an immediately invoked function expression. So it's, if you want to make it simple, you just do something like this and like this. Then you come here and write your logic, leaving the second parenthesis empty. You do something like a function. Open this, then you say, oh, you have, let's private prop is equal to, hello, I am private. And we also have a private function private function log I am private. Then you want this function to actually return the public method you need. You say public variable is, say I am public, or actually a function, a public method that is a function that simply logs I am public to the console. So what if you want to use this, you can simply say module dot, you can see the public method and the public variable and the public method. These private methods are internal and you cannot access them. So you can see module dot public variable. Then you can simply log that to the console. Something like this. Oops. Oops. Yes. There's a node. See, I'm public. You can do something like public method, and this is actually a function, so you invoke it. Oh, it already has a console in it, so we don't need to console it. It's returning nothing. And just say it like this. See, I am public. I am a public function. See, I'm public. You cannot access this. If you try to say module spread, you get an error. Okay, you know, save the file. Say log something like this. Undefined, because this is undefined. The private is undefined. It's not accessible from this function. That is creating the module. So exporting public interfaces. This one is exposing the public interfaces which you want the users to get access to. The revealing module pattern helps encapsulate implementation details and promote information hiding, as I earlier said. This can be particularly useful when developing larger applications, as it helps prevent accidental modification of private variables and promote a clear and separation between public and private functions. So in this file, you can simply say module.exports. You can say is equal to mod. You can come here and create a file test.js and say, oh, I like to import things const let's see, index const index module is equal to require index. Then you see log index module dot, and you can see the method, the method and the variable here. You can see the method and then you invoke it. Then if you run it, it still works. Node test, yes. Oops, always making this mistake. You have like this, and it still works. I'm a public function, so this is how you can create. And outside of this, you can see here we have this private properties, but you cannot access them outside. You can only access the interface exposed to you to be able to like use them. So, oh, wow, that's nice. We've come a long way. That is just the revealing module pattern. I will have the defining a module. So, you know, just modules play a crucial role in organizing and structuring your data, your code. So modules allows you to encapsulate functionality, as I've been saying, reuse code across different parts of your application and promote better code organization. There are a few ways to define and work with modules in Node.js. We have the common JS. The common JS, I talked about this earlier. Let me just see cjs.js. CJS, where you see, okay, we have const add is equal to a b, then you return a plus b with arrow functions. And subtract is equal to a b a minus b. Then you say exports dot add is equal to add. Then exports dot sub is equal to sub. You can come here and see, actually comment this out. You see const CJS is equal to require CJS. If you want to use the add function, you can see log CJS that subtract 2 from 3. Or you can see this add 3 to 2. No, what is this? Subtract 2 from 3, or you can say add 2 to 3. And this will work. You see node test.js. We have, oops, this is a comma, not addition. We have 1 and 5. 3 minus 2 is 1, and 3 plus 2 is 5. Or you can simply say import everything as CJS. No. Just like this. I'm mistaking it to be modules. Not this command JS doesn't do that. You can simply do something like this. Or if you don't want it like this, you can say import add and subtract from common JS. Then we do away with this CJS. Do away with also this CJS. And then you test it out and it works. And if you don't want to export it like that, I actually do something like this. What is this? Also, this is a module.export is equal to add subtract. It still works. It depends on your use case, how you want your code to be when it's working. You can say CJS, then say CJS JS.add the subtract, and you still work. You can do something like that. You can still say subtract. Oh, not modules, add. This. And then you do away with your CJS. It will work very fine. So that is common JS. Notice what we are doing here. Export that add export.sub. You can even say something like export.name is equal to hello, or export.greet. Then you can then do away with this and then come down here and then see log. And say greet. Like this, log greet. Test it out and you see hello. You can export anything, an integer, strings, any other thing that's all you want to. And it will work. So that is what are we looking at again? Defining a module in using common JS. So ES modules, next we'll be looking at ES modules, import and export. We can have a new file, which we have CJS, common JS, then we have ESM.js, where you can see, actually, we can just come here and copy all of these things. This, then bring them down here. And then you can see something like export. Export. Then you can come down to your test file and say import from next, that is esm.js for module resolution in NodeJS. If you don't specify the JS, the node will know the kind of file you are importing. Is it JSON? Is it JS? Or is it a Python file? Node doesn't know. So you can simply say add and subtract. Then you log this to the console, but this won't work. Add 2 or 3 because Node doesn't know anything about ES modules, ES6 modules. So what you want to do is you want to initialize a package of JSON file in the root project of your application where you want to use it. Then come down here. Here you see the type of modules you want to use is module, not common JS. And right now you can be able to use it with no problems. You can simply say node test.js, and it's working. Or if you don't want to do it like that, you can say something like import everything as math operators from then you can say math operator dot add, and it will still work. It's still working. Or you can say math operator dot subtract. It will work perfectly. Then you can come back here and say, oh, I don't want to export this thing like this. Like me, I don't like doing this. I will just do like this. Then come down here and export everything. Export, add, and sub. Then you come down here and then test your code, and it's still working. If you don't want to do it like that, you can still return to your normal export. Or all you can do is no, here. All you can do is, let me just copy this and then comment it out. You can see export this, add and subtract. Okay, that is another method. You can come down here and see export default. And you can add, this can be a function that takes in and return add A and B and returns the result, or another function. Hey, my internet is unstable. Okay, okay now. And subtract in the function A minus B. And then say math operators. Then you can come down here and then comment this out. You say import everything as math operator. Then you say math operator dot default log math operator. Would you not prototype default function math operator? Okay. Oops, error, math operator is not a function. You can say import math operator. Any name. You can say math operator dot we returned add function here. Is any mistake? Return add this. Okay. A B. I'm not making any mistake. My dot add not operator dot it dot math. What is it? A B. What is this? It's a single function. Okay. export default function multiplicator log hello. Simple things we want to frustrate you sometimes. This is actually a default function, so it's not like this will work. Or am I making any mistakes? I'm just a kind of weak. Let me check again. This is not supposed to be frustrating. Let's put default function. Okay, spot. This one like this. Yeah. A mistake from me somewhere, but that's it. That's how to define a module using defining modules using common JS or ES module. And now built-in modules, and then the third-party modules known as the NPM packages. Built-in module, you can simply, after installing, let's say you've installed Axios, so you can simply say const Axios is equal to require Axios from Axios, something like this. And then you can go ahead and use Axios, same as Express. Then built-in modules, you can see these are third party. Then we have built-in modules that we'll be looking at next in our next class. You can say const fs, the file system is equal to require file system, or you can say import fs from node fs. If you want to use asynchronous fs or the promise or not fs, or you can simply say import fs from fs, and that's cool. You can go ahead and use it. So we've learned how to use the common JS, the ES modules, the third-party modules, and then the built-in modules. What's left? Module definition patterns. This is not quite different from defining modules. The patterns is no difference there. In Node.js, exporting modules refers to making parts of your code, like such as variables or functions or classes or constant or anything available for use in other files or modules. There are different ways to export modules depending on the module system you are using. The two primary module systems in Node.js are CommonJS and ES6 modules that we've discussed about. So the methods, there's no difference there. So we don't have to go ahead and then keep looking at all of that. They require /exports, the imports and exports, the module export.module, the module.export, and all of that. You can even export classes. Yes, we can import classes. You can do something like let's say for instance we have, let's come here and see, we have a class. Class of module. You will simply, what is this? No, class module. And then we do this thing. See, module dot export is equal to new module, like this. Then we can actually come down here and see we actually come down here and see okay, yes, you can say import mod from index.js. Then we can do something like const I1, that is instance 1 is equal to new mod. New mod I2 is a log A1 is equal to I2, like this. Error mode for users. Let's see. Provide an export name default. This is using common JS. You can say export default. Export default like that. Still see, mod is not a constructor. Why is it showing mod is not a constructor? Mod is not a constructor. You can actually see constructor. Yeah, Moses, go ahead.
The M should be capital letter.
You sure? This is a default export. This is a default export. Okay, let's see.
I mean the import. Yeah.
Still the same thing. Okay. Let's
export the instance. Then we are using the instance we import. We also create another instance from the instance.
sure. I want to handle that. Let's see if I can handle it. And let's see now if it gives us an error. Oops. Okay, at this point, let's remove this. Let's see. Error again. This is not supposed to throw an error directly. Okay, it's now working. So this is equal to this, the same instance. So it will return true, actually. So that's how we work with ES modules and common JS. As you can see, this is a default. So in review, what we've done, we've looked at the NodeJS philosophy, design fundamentals, the reactor pattern, the callback pattern, module system, and its patterns. The observer pattern, I will leave it for you to make some research on it. We discuss the reactor pattern, the blocking IO, the event demultiplexing, non-blocking IO engine of NodeJS, the libel VAs and bindings on all of that. What makes up NodeJS? The callback pattern, asynchronous continuous passing style, the NodeJS philosophy and design fundamentals, which we looked at the module system and its pattern as a sub concept, the revealing module pattern, defining a module, and all of that. So we've come to the end of today's class. Is any questions? And I will find, maybe we're going to be there's going to be a video that will teach you how to create pull requests and then tag reviewers. So after that video is created, every of your projects, you create a special repo for KodeCamp, then you add me as a contributor. So every of your project, you create a pull request and you tag me as a reviewer. So that will directly, GitHub will notify me and I'll directly review your code, and then but you still submit the link on the LMS. But that is yet to be decided. So you continue doing your project and continue submitting the links to the LMS till the final decision is taken. Okay. So any questions so far?
Yeah, I have a question, sir.
Yeah, go ahead.
One more thing, like yesterday, I just submitted my assignments. Hope I'm not too late, sir.
Okay.
So I would like you to help me to review it, sir.
Okay. But you passed the deadline. What's happened?
Actually, I didn't know there was a platform like LMS, so I just checked yesterday. Then I quickly finished the assignments. I'm sorry for the lateness.
Okay. Maybe you've not been active on Discord. Try to be at least checking your
I've
Discord
been
server.
active. I've been active. I always come to Discord.
Okay.
I always come.
Keep checking the
But
announcement channel regularly. All of the announcements are
okay,
posted on the announcement channel.
okay, sir. Thank you.
Okay. So thank you, and see you on Thursday.